Section 5.4 is complex numbers. Imaginary numbers are complex numbers. When you have a negative inside of a square root, you can turn that into an imaginary number. So anytime you see square root of -1, you can replace it with I. And anytime you see I squared, you can replace it with -1. So square root of -4 would be 2I. The long version of that would be, you could rewrite that to say -1 times 4. And the square root of -1 is I, and the square root of 4 is 2, so that would be 2I. Square root of -9 is 3I. Square root of -16 is 4I. Square root of -25 is 5I. Square root of -36 is 6I. And square root of -49 is 7I. Simplify. Square root of -27. All right, we need to break this radical down to where one of the factors is a perfect square. And when you break it down, put the negative with the perfect square. So I'm going to break that down to -9 times 3. Square root of -9 is 3I, but we can't take the square root of 3, so that stays inside the radical. Square root of 216, I need to break that down to where one of the factors is a perfect square. Well, you could use your calculator to help you. 216 divided by 4 is 54. So if 4 works, you should always try 16. 216 divided by 16 does not go into it evenly. So now let's try. So we tried 4, that worked. We tried 16, that did not work. So let's go and try 9. And 9 goes into 216 evenly. So if 4 goes and 9 goes, then square root of 36 is a perfect square. And square root of 216 divided by 36 is 6 times. So we're going to break that down to -36 times 6. Square root of -36 is 6I. Can't take the square root of 6, so it stays inside the radical. Example C, square root of -18. I'm going to break that down to square root of 9 times 2. Square root of 9 is 3I. Cannot take the square root of 2, so it stays inside the radical. Example D, square root of -125. Well, I know that 25 goes into -125 5 times. So I'm going to break that down to -25 times 5. Square root of -25 is 5I. Square root of 5. Remember what I said earlier about I squared is -1. So anytime you have an I, you can break it down in the form of I squared. I to the third, I'm going to break that down to I squared times I, because remember, when you multiply variables, you add the exponents. And imaginary numbers are exactly the same as variables. So I squared is -1. We're going to replace that with -1 times I is -1I, or we can just say I. I to the fourth, I'm going to break that down to I squared. Remember, power of a power, we can multiply the exponents. And again, anytime we see I squared, we replace it with -1. So that's -1 squared, which is a positive 1. I to the fifth is I squared squared times I, because that gives us I to the fifth. And I squared, again, is -1 squared times I. -1 I squared is 1 times I is 1I, or just I. I to the sixth, we're going to break that down to I squared to the third power, which is -1 to the third power. and negative 1 to the third power is a negative 1. Remember, if the exponent is even, the answer is positive. If the exponent is odd, the answer is negative. I to the 7th, we're going to break that down to I squared to the third, and then we have to multiply it times an I. So that's negative 1 to the third power times I. Negative 1 to the third power is negative 1 times I is a negative 1I, or we can just say negative I. Example 2, negative 5I times 3I. We're going to multiply our constants together. Negative 5 times 3 is a negative 15. I times I is I squared. Now I squared is negative 1, so we're going to replace it with negative 1, and then multiply negative 15 times a negative 1 is a positive 15. Example B, square root of negative 6 times the square root of negative 15. Always turn your radicals into imaginary numbers first. So square root of negative 6, that's I square root of 6. And square root of negative 15, that's I square root of 15. Then we are going to multiply our i's together. I times I is I squared. Now we multiply our radicals. Square root of 6 times square root of 15 is the square root of 90. Now I squared, once again, when we see I squared, we replace that with negative 1. And square root of 90, I'm going to break that down to 9 times 10. Square root of 9 is 3, and it comes out of the radical. And when it comes out, I multiply it times that negative 1 to give me negative 3 square root of 10. Example C, 3i times 4i is 12i squared. And once again, whenever we see I squared, we replace that with negative 1. So my final answer is negative 12. Example D, again, I have to turn my negative radicals into an imaginary number. Do not multiply them together. If you do, the negatives go away, which would turn into the wrong answer. So I'm going to break this down to negative 4 times 5. And I'm going to break square root of negative 12 to negative 4 times 3. Square root of negative 4 is 2i. Cannot take the square root of 5, so it stays inside the radical. Square root of negative 4 is 2i times square root of 3. Now I'm going to multiply my coefficients together. 2i times 2i is 4i squared. Square root of 5 times square root of 3 is 15. We're almost finished, but we're not finished yet, because anytime we see I square, we will replace that with negative 1. So negative 1 times 4 is a negative 4 square root of 13. Now we are finished. Example E, I to the 31st power. We are always going to simplify it in the form of I squared. Now, can I multiply 2 by some number to give me 31? No, but I can come close. I can get 30, so I can multiply it by 15, and then I have to multiply by an additional I to the 1 power. I squared is negative 1 to the 15th power times I. Negative 1 to the 15th power is a negative 1. Remember, if the exponent is odd, the answer is negative. Times I is a negative 1i, or we can just say negative I. F, I am going to multiply negative 3i times 2i and get negative 6i squared. Whenever I see I squared, that replaces the negative 1. So my final answer is 6. H, we are doing the distributive property. So, I'm sorry, we're multiplying two binomials together, so we do the FOIL method. 4 times 6 is 24. My outside is a negative 24i. My inside is a negative 6i. And my last, that's negative 6 times a negative 6 is a positive 36i squared. I can combine my two i's and get negative 30i. And then I squared, again, replaces negative 1. So negative 1 times positive 36 is a negative 36. Now I'm going to combine 24 and a negative 36 is a negative 12 minus 30i. G, I'm going to do the FOIL method. I get 18 minus 4i plus 45i minus 10i squared. Negative 4i and a positive 45 is a positive 41i. I squared is negative 1. So negative 1 times a negative 10 is a positive 10. Combine 10 plus 18 is 28 plus 41i. Now notice that when you're dealing with imaginary numbers, you are putting the constant first and then the variable. And then the imaginary number. So the imaginary number always goes last. Example 3, we are going to solve. So if this said 4x squared minus 256, that would be a difference of two perfect square, and you could factor. Actually, you'd have to factor out a GCF first, but anyway, you could factor into two binomials. This is not a difference of two perfect square because it says plus 256. So we have to solve this by trying to get x squared by itself. So we're going to subtract 256 from both sides. Then we are going to divide each side by 4. And 256 divided by 4 is 64. And that's a negative, by the way. So that's a negative 64. Now, anytime we want to get x by itself, and it says x squared. So to get x by itself, we take the square root, because when you square a square root, what's inside falls out. So taking the square root of something that you're squaring, that's the opposite. But rule of algebra, what you do on one side, you must do on the other. The square root of negative 64 is 8i. Now, anytime you are solving an equation and you are taking the square root, you must give it a plus or minus sign. So it's a plus or minus, meaning positive 8i and a negative 8i. There are your two answers, positive 8i and negative 8i. But normally the way we write it is just plus minus right underneath. Example 3b, we're going to subtract 100 from both sides. It's not a difference of two perfect square because of that positive 1. Divide both sides by 4. And you get x squared is equal to negative 25. And take the square root. So that's x is equal to plus or minus. The square root of negative 25 is 5i. Example 3c, we're going to subtract 4. Take the square root. So x is equal to plus or minus 2i. Example D, we're going to subtract 20. Divide by 5. So y squared is equal to negative 4. Take the square root. So y is equal to plus or minus 2i. I said earlier that a complex number can be written in the form of a plus bi, where the imaginary number is last. Here's an example, 5 plus 2i or 1 minus 3i. That is the way you would always write complex numbers. Example 5, we are going to simplify. These two parentheses we are adding, so we have to clear the parentheses. In the very first parentheses, there's nothing in front of it, which is understood to be a positive 1. So we just drop the parentheses and rewrite it. And the second parentheses is a positive, so we just drop the parentheses and rewrite it. Then we're going to combine like terms. 5 plus 2 is 7. Negative 7i and a positive 4i is a negative 3i. Now, example B, we are subtracting. So, once again, the first parentheses we just recopy. But in the second parentheses, there's a negative, so we have to distribute the negative out. Combine like terms. 4 minus 3 is 1. Negative 8i and a positive 6i is a negative 2i. Example 7. We cannot have imaginary numbers in the denominator, so we have to do whatever it takes to get rid of it. When you have more than one term in the denominator, to get rid of the I, you would multiply by the conjugate. The conjugate is a fancy word for the opposite. So the conjugate of 3 plus 6i is 3 minus 6i. So I am going to multiply the denominator by 3 minus 6i. Rule of algebra, if you do it on one side, you must do it on the other. If you do it on the bottom, you must do it on the top. So I'm going to multiply the top by 3 minus 6i also. I'm going to do the distributive property. 2i times 3 is 6i. And 2i times a negative 6i is a negative 18i squared. Now in the denominator, I'm going to do the FOIL method. That's 9. My outside term is a negative 18i. My inside is a positive 18i. And my last is a negative 36i squared. Now notice my two middle terms went away. When you multiply by the opposite, the two middle terms are always going to go away. So a shortcut, instead of doing the entire FOIL, is just do the first and the last. Okay, so let's clean this up a little bit. Remember, I squared gets replaced with negative 1, so that's 6i. Negative 1 times a negative 18 is a positive 18. The denominator, this I squared gets replaced with negative 1, so that's 9 plus 36. Okay, I'm going to rewrite this. Remember, always have your constants first, then your imaginary numbers. And then I'm going to add 36 plus 9, and I get 45. Now we need to separate this. We need to reduce this. So put each term in the numerator over its own denominator. It should be just a 6, not a 6i. And then 6i over 45. And then we can reduce each fraction. 9 goes into 18 2 times, and 9 goes into 45 5 times. 3 goes into 6 2 times, and 3 goes into 45 15 times. Okay, I just found another error. This should be 12. I don't know how to multiply. Okay, 3 goes into 12 4 times, and 3 goes into 45 15 times. Now, if you wanted to, you could go back and put it over one denominator. That is the way it's probably written in the back of the book, the answer. Okay, example 7. We have to multiply by the conjugate, which is 3 minus 5i. And I'm going to multiply the top by 3 minus 5i. So I'm going to do the distributive property. That's a negative 2i times 3 is a negative 6i. And negative 2i times a negative 5 is a positive 10i squared. Now, in the denominator, I already know that when I do the FOIL method, the outside and the inside term is going to go away, so I'm going to skip that part and just do first and last. So that's 9 minus 25i squared. So let's clean this up a little bit. That's negative 6i. I squared is a negative 1, so negative 1 times 10 is a negative 10 over 9 plus 25. So that's negative 10 minus 6i over 34. Then I'm going to simplify it by putting it over each over its own fraction. So that's negative 10 over 34 minus 6i over 34. And I'm going to reduce that to negative 2 over 17 and a negative 3 over 17, or 3i. You can put it back all over 1, negative 2 minus 3i over 17. And example C, I am going to multiply by the conjugate, which is 1 plus I. Now in the numerator, I'm going to have to do the FOIL method. So that's 2 plus 2i plus I squared. In the denominator, I only have to do the first and last, so that's 1 minus I squared. It's 2 plus 3i minus 1, because I squared replaces with the negative 1. And this replaces with the negative 1. So that's 1 minus a negative 1, which is plus 1. 2 minus 1 is 1 plus 3i over 2. Now, 2 cannot go into 1, and 3i over 2. That cannot reduce that, so I don't even need to go that step. I'm done. And that is the end of section 5.4.